Hello everyone. In this video, we are going to discuss Newton's law of cooling. Newton's law of cooling states that the rate of change of the temperature of an object is proportional to the difference between its own temperature and the temperature of surroundings. We use the notation capital T of little t to represent temperature of the object at moment t, and S to be the ambient temperature. So the differential equation to describe Newton's law of cooling is the rate of change of the temperature of the object, d capital T over little dt, is equal to negative k times capital T minus S. This is a simple differential equation to solve because it's separable. So we can move capital T minus S to the left-hand side by dividing that factor on both sides, and then move dt to the right-hand side. Now we integrate both sides of this equation. So the left-hand side is natural logarithm of absolute value of t minus s equals negative kt plus c1. So notice here the absolute value is very important because the temperature difference between the object and the surrounding could be positive or negative. And we take the exponential on both sides to get rid of natural logarithm. So the left-hand side is absolute value of t minus s equals the other side e to the power negative kt times e to the power c1. And then we can use another letter c2 notation, c2 to represent the object constant e to the power c1. And here c2 is positive, but we have absolute value on the other side. So in the end, we eliminate the absolute value sign by replacing c2 with another letter c, object constant, which could be either positive or negative. And in the end, we leave t by itself by adding s on both sides. So t, capital T, is equal to s plus c times e to the power negative kt. So if c is positive, then this solution describes Newton's law of cooling, because e to the power negative kt is a decreasing function. And if c is positive, which means the t, capital T, is decreasing over time t, over time. So it's a process of cooling. If c is negative, and because e to the power negative kt is decreasing function, that resulting in c times e to the power negative kt is increasing function. So the solution will describe a heating process. Let's look at an example. A metal object is heated to 200 degrees Celsius and placed in a larger room to cool. The temperature of the room is held constant at 20 degrees Celsius. After 10 minutes, the object's temperature is 100 degrees Celsius. How long will it take the object to cool to 25 degrees Celsius? Understand our differential equation is d capital T over T dt is equal to negative k times capital T minus s, and our solution is capital T of t equals s plus c to the power negative kt, which is exponential function. So recognize the value of s, which is the room temperature in this case, is 20. And also the initial temperature of the object is 200. So T of 0 is equal to 200. And also we have the information after 10 minutes the object temperature is 100 degrees Celsius. So T of 10 is equal to 100. So now let's plug in all those information to our general solution and apply the initial condition. So T of 0 equals 200 implies 200 is equal to 20 plus C times e to the power negative k times 0, which implies C is equal to 180. So C is the value, in this case, the difference of temperature of the object and the room. And the second initial condition, T of 10 equals 100 implies 100 equals 20 plus 180 times e to the power negative k10. So 80 is equal to 180 times e to the power negative k10. And you solve k is equal to negative 1/10 ln 80 over 180. Simplify a little bit, so that's negative ln 4/9 over 10. I will keep this expression as exact value for k, and then plug that value back to the solution. So T of t, particular solution, is equal to 20 plus 180 e to the power negative ln 4/9 over 10 times t. Simplify a little bit algebraically. T of t is equal to 20 plus 180 e to the power ln 4/9 over 10 times t. So the question is, how long will it take for the object to cool to 25 degrees Celsius? So 25 is the value of capital T. We can plug that value to the particular solution, 25 for capital T, and then solve little t to figure out how long it takes. So now we have a very straightforward algebraic equation for little t. So we need to leave t by itself. So we need to subtract 20 on both sides, then divide by 180, then take the ln to eliminate the exponential e. And then in the end, you have to divide by the coefficient of t, so which is, because it's fraction, so it is multiplied by reciprocal 10 over ln 4/9. And you can punch that to calculator. The answer is t equals 44.2 minutes. Alright, that concludes this video. Hopefully you'll find it helpful to for your homework questions. Thanks for watching.